Hello dreamers, and welcome back to Bedtime Universe. Tonight we will drift together into a quiet corner of the cosmos, a place where curiosity hums softly and the sky keeps its secrets like whispered stories. Make yourself comfortable. Breathe in slowly, breathe out slowly. Let the day loosen its grip and allow your thoughts to unfurl like thin ribbons of starlight. This is the story of a visitor from beyond, a small, cold messenger that crossed the vast darkness between stars and, for a brief while, threaded itself into our sky. Scientists call it Three-Eye Atlas. To many, it has become a puzzle. To some, a warning. To others, a doorway. Tonight, we will walk that doorway together, slowly and gently, listening to the strange hints it left behind. Long before our sun kindled, before our oceans gathered on an infant Earth, this object was already on its way. Imagine a world of distant suns, a disk of dust and gas circling some ancient star. Somewhere in that pale, crowded neighborhood, an ice fragment formed. It lived a quiet existence as part of another system. Then some violent event sent it adrift. Over time so vast, they make human memory feel like a single blink. That it crossed the empty dark, carried on the indifferent currents of the galaxy. That was its first long sleep. Then, in our era, in the small window of human attention and telescopic looking, telescopes noticed a faint motion. It showed up in the regular feeds and alerts, a dot moving with an unusual speed and path. The networks named it Three-Eye Atlas. The first two had already taught us to be humble, but this one arrived with riddles that were sharper and stranger than anyone expected. At first glance, the numbers were puzzling. Its trajectory was hyperbolic, which means it was not bound to our Sunday. It came from far beyond, on a one-time crossing. It moved in a retrograde direction, traveling opposite the familiar sweep of the planets. Yet its orbit lay almost along the same plane that the planets occupy, inclined at only about 5 degrees. That combination, retrograde motion but low inclination, felt statistically odd. It was as if a traveler arrived along a road parallel to ours, but going the other way. The geometry of that passage made some astronomers quiet with curiosity, because coincidences like that, if truly coincidental, are rare. If it were not coincidence, what else might the path be telling us? Further observations unfolded the stranger truths. At nearly 3 astronomical units from the Sun, at a distance where comets built in our own system usually slumber and preserve their ices, this visitor uncoiled as if waking. It released water vapor in massive amounts, when most familiar comets do nothing at all. Not just a slow drip, but a surge. The activity at 2.9 AU contradicted the expectations of ordinary cometary physics. Even more surprising, when scientists analyzed the gases in its coma, the ratio of carbon dioxide to water turned out to be exceptionally high. For every part of water, there were 8 parts of carbon dioxide. That 8-to-1 ratio is unlike anything seen in comets that formed in our cold backyard. Carbon dioxide dominated the chemistry of this strange halo of gas. The spectrum of light the object reflected told another story. It was not simply bright or dim, but it polarized light in ways that did not match known cometary behavior. Polarimetry, measuring the oscillations and directions of light waves, revealed anomalies. The patterns suggested unusual dust geometry, perhaps grains with internal structures or surfaces that scattered light in unfamiliar ways. The polarization signatures bore a negative extremity and phase angle changes that defied standard models. When faced with such data, astronomers do what they always do. They measure again. They cross-check instruments. They test for error. The anomaly persisted. And yet, one more disquieting paradox emerged. When large amounts of gas are expelled from a small body, physics dictates a recoil. Gas jets act like microscopic thrusters. Over time, they nudge an object off a purely gravity-determined orbit, producing measurable non-gravitational acceleration. This is well known and accounted for in cometary dynamics. But the non-gravitational acceleration measured for 3I Atlas was far weaker than the observed prodigious gas release should have produced. The magnitude of the gas flux suggested a stronger push. Instead, the object seemed stubbornly steadfast, barely perturbed. This mismatch created a tension between observations that demand explanation. On one side, large gas emissions, extreme CO2 dominance, odd polarimetric behavior, a retrograde, hyperbolic orbit with a low tilt. On the other, a weak, non-gravitational acceleration inconsistent with the scale of outgassing. If the outgassing were real at the observed scale, the body must be much more massive and thus larger than some estimates allowed. If it were massive, how could it have formed with such an unusual composition and surface behavior? If it were small, why was it not being accelerated? Estimates for the size of its nucleus varied wildly. Some analyses suggested a compact body less than half a kilometer across. Others allowed for diameters up to 5 or 6 kilometers. The difference between those numbers is not small. It changes mass and inertia by enormous factors and flips the calculations that follow. When scientists encounter such a thicket of contradictions, they must do what science exists to do: gather more data, broaden hypotheses, and be willing to consider uncomfortable possibilities. The most conservative approach is to imagine that 3I Atlas is an extreme yet natural variant of cometary physics. Perhaps it formed in a region of its parent system where volatiles other than water accrued preferentially. Certain formation environments could produce cores rich in carbon dioxide, with layered structures that release gases in unusual bursts. Perhaps the internal porosity or compactness is different, trapping or channeling gas in a way that changes the effective thrust. Perhaps rotational dynamics spread jets in directions that cancel net impulse. Each of these is plausible and can be folded into models, though with significant adjustments. A more daring line of thought moves into deeper waters. Some researchers whispered of a black swan event in astronomy, an occurrence so rare and consequential that it forces the revision of assumptions and frameworks. The term black swan had traveled into astrophysical discourse because sometimes unpredicted anomalies have reshaped how we think about the natural world. Could 3I Atlas be such a moment, nudging us toward new understandings of material behavior, of small body dynamics, or perhaps even of physical law at particular scales and configurations? This is not to suggest headline-grabbing claims about broken gravity or overturned relativity. Science does not leap to such conclusions lightly. Instead, the suggestion is more measured. Maybe there are processes, combinations of microstructural geometry, phase change dynamics, and radiative interactions that are not yet captured by our current models. Maybe on the surface of 3I Atlas, microscopic layering, exotic ice phases, or mineral coatings produce behaviors that defy the simplified assumptions built upon solar system observations. Or perhaps there are kinds of feedback between surface chemistry and gas release that, under particular conditions, create near cancellations of thrust on macroscopic scales. These ideas remain speculative until they are tested. But they are worth considering because the alternative, ignoring the mismatch, would be to stagnate. Meanwhile, the human side of this story plays out with a mix of methodical diligence and restrained imagination. Observatories across the globe trained instruments on the visitor, Radio telescopes listened for molecular lines. Infrared arrays mapped thermal signatures. Polarimeters tracked the strange polarization. Teams coordinated observation schedules in near real time, aware that the window for meaningful data would not last forever. In the quiet nights of observatories, technicians adjusted filters and recalibrated detectors. Graduate students wrote scripts to sift terabytes of data. Senior scientists organized teleconferences at odd hours. It was, in many ways, a classic example of how modern science answers the call of a rare phenomenon, with cooperation, redundancy, and patience. At the same time, communities of amateur observers contributed images and time series that filled the gaps between professional facilities. Citizen science platforms aggregated visual confirmations and photometric data. Each new spectrum and photometric curve fed into global databases. Models were adjusted, then tested. Some parameters tightened, others remained obstinately uncertain. Uncertainty, here, was not a failure. It was the currency of honest knowledge. Public communication became a tightrope. In a world where every unusual astronomical headline can be amplified into sensational claims, scientists and communicators worked carefully to distinguish robust results from preliminary speculation. The press wanted stories, and the public wanted wonder. Both were valid, but fidelity to nuance was essential. Researchers were cautious to say what the data truly supported. Anomalies were present, they were significant, and they invited deeper study. Beyond that, the community avoided leaps. Speculation about black swan scenarios was framed as a useful intellectual exercise, not as a declaration of revolutionary physics. Within the labs and online forums, different narratives emerged, like competing constellations in a dark sky. They pointed to known chemical processes and proposed that the CO2 dominance could be a formative signature, reflecting a birthplace with different temperature histories and volatile reservoirs. If so, then 3I, Atlas, is a message about diversity. Planetary systems can produce bodies with substantially different volatile budgets, and our models must be flexible enough to embrace them. Others focused on morphology. If the nucleus were highly structured, with massive subsurface cavities, or an asymmetric distribution of volatiles, the outflow could be more complex than a simple rocket effect. Jets could be balanced by counterjets, or the geometry of mass loss could distribute momentum in ways that net to small acceleration. Laboratory experiments and computational models began to explore three-dimensional porosity and jet dynamics at scales relevant to cometary nuclei. These endeavors required time, but they also yielded insights that could be applied to future encounters. Then there were the theorists who considered more exotic but testable physics. They did not stake their reputations on overturning pillars, but they examined whether known laws might permit subtle, scale-dependent effects under unusual compositional or structural regimes. They asked if phase changes involving clathrate ices or complex organics could lead to delayed or buffered outgassing. They calculated whether radiative torques or photophoretic effects could conspire to counteract the direct momentum transferred by jets. These models were complex, layered, and, crucially, falsifiable. That made them worthy of attention. All hypotheses required better constraints on basic numbers. The wildly varying estimates of nucleus size were a particular problem. A 5-kilometer core and a 300-meter core imply orders of magnitude difference in mass, and therefore in how the object would respond to any thrust. Pinning down size required clever analysis, combining thermal emission measurements, limits from brightness, scattering properties from polarimetry, and dynamical fits that accounted for possible non-gravitational forces. It was painstaking work, and it highlighted how a single parameter of uncertainty can ripple outward into many interpretive paths. As people around the world looked up, small human stories accumulated like stardust. Teachers used the anomaly as a lesson in science clubs. Poets wrote short lines about an ancient messenger slipping silent through the night. Children asked questions that prompted simple, honest answers. Why does space have different kinds of comets? Could something like this happen again? The emotional resonance was gentle too. There was a shared sense of being part of a living inquiry. The public learned how science contends with surprises by being systematic, skeptical, and open to revision. In the end, 3I Atlas may turn out to be a deeply instructive oddity that teaches us about the diversity of planetary systems. It may be a case study in how early formative environments shape volatile inventory and microstructure, or, in time, it could expose processes that require extensions to our current models. Whatever the final verdict, the encounter is already valuable. It has focused attention on the need for rapid, coordinated observation strategies for fleeting interstellar visitors. It has highlighted the importance of cross-disciplinary work, combining observational astronomy with laboratory astrophysics, advanced modeling, and comparative planetology. There is a quiet lesson in the way this story unfolded. The universe does not owe us simplicity. It may occasionally present us with an object that resists tidy categorization, demanding patience and humility. That resistance, strangely, is not an obstacle to wonder. It is the engine of knowledge. When an anomaly appears, the right response is not to rush to conclusions, but to widen the aperture of inquiry, to bring more eyes to the sky, and to sharpen our instruments and our questions. So as you allow sleep to come, picture 3I Atlas sliding further into the velvet of interstellar space. Imagine it as an ancient traveler that carries within its frozen heart the chemical memory of another star. It moves forward, indifferent to our theories, but intimately entangled with our curiosity. We will continue to watch, to measure, to calculate, and to wonder. We will return to its story as more data come in. And with every new piece of evidence, our map of the cosmos becomes a little more elaborate and a little more true. Breathe in, breathe out. Allow the questions to rest for the night. Remember that uncertainty is part of the beauty of science. It is the seed of future certainty, the quiet engine that pulls us gently forward. Tonight, in the shadows under the same sky where an interstellar wanderer once sped by, you are connected to a long chain of observers. Those who listen, those who measure, and those who imagine. Good night, dreamer. Good night, bedtime universe. Until the next story, may curiosity lightly guide your sleep. All right, the next story we settle into is about deep time, the faint hum of cosmic interconnection, and a mystery that only began to unfold when everything in the outer solar system aligned in a way no physicist thought possible. This is the tale of Project Lachesis and the unsettling whispers carried on the solar wind during the solstice of Eridanus. Part 1. The arrival of the rogue shepherd. In the cold, perpetual darkness that lies beyond the Kuiper Belt, past the final, lonely sentinels of ice and rock, a celestial body was moving. It wasn't a comet, pulled by the sun's fierce gravity. It wasn't a Kuiper Belt object, tethered to the ecliptic plane. It was an object catalogued as Xylos, a rogue exoplanet, roughly the mass of Mars, traveling on an impossibly shallow hyperbolic trajectory that was bringing it into our Oort cloud, yet not towards our Sunday. Imagine the Oort cloud, that vast spherical shell of icy debris as the very edge of our sun's dominion, a shimmering, silent boundary between the known and the interstellar void. For millennia, It has remained undisturbed, a frozen record of the solar system's birth. But Xylos, this quiet, dense traveler, was slicing through it like a ghost ship through heavy mist. The scientists at Project Lachesis, operating out of a subterranean complex in the Atacama, initially dismissed it as a statistical anomaly. Xylos was too dense to be a captured object, too distant to be a planet, and its velocity was subtly wrong. It was moving too slowly, yet with an inexplicable rotational frequency. Dr. Elias Thorne, head of the project, often described it to his interns as a silent shepherd, because its passage wasn't causing gravitational chaos. Instead, the distant cometary bodies ahead of it seemed to be settling, their orbits becoming unnaturally orderly, as if drawn into a state of subtle rotational peace. This state of uncanny quietude was the first clue. Gravity we understand, chaos we anticipate. But this induced cosmic order suggested a force that was less about brute mass and more about resonant fields. Xylos was not just moving through space, it was interacting with the fabric of space-time in a way our current models could only vaguely predict, leaving a wake of unnatural stillness in its path. We often forget that space is not empty. It's a plasma-infused medium, a vast electrical conductor, and Xylos seemed to be tuning it. Part 2. The Silence of the Sentinel. Roughly 2 months after Xylos's initial detection, and just as it entered the inner Oort cloud boundary, our attention was wrenched toward the very frontier of interstellar space, Voyager 1. The oldest, loneliest messenger humanity has ever launched, now traveling through the turbulent, magnetically active realm of the interstellar medium. For decades, Voyager's plasma wave subsystem had been sending back a steady, albeit faint, recording of the density and magnetic pressure outside the Sun's influence. It was the sound of space, a low, oscillating hum. Then, at 3:17 UTC on the morning of the solstice, the hum stopped. Not a sudden catastrophic failure, which would have indicated a micrometeorite strike or power loss. Instead, the data stream showed a perfect, complex harmonic spike, a signature so mathematically pure, it initially triggered a data corruption warning. The spike lasted exactly 4.83 seconds, and then the plasma wave detector went dead. Silence. A digital void that stretched for 3 hours before the system miraculously rebooted, only to report normal but inexplicably weakened background noise. Dr. Thorne, a man who rarely used adjectives stronger than noteworthy, called the initial 4.83-second burst a signature of deliberate compression. The energy was not random. It was structured, like a perfect chord struck on a gigantic interstellar string. It suggested that a colossal wave of structured energy, perhaps an extremely low-frequency electromagnetic pulse, had washed over the probe. A wave that carried a pattern, not noise. What was the common thread? Xylos was still hundreds of billions of kilometers away from Voyager, yet the moment of the signal's emission was calculated to have perfectly intersected with the time Xylos crossed a major heliopause boundary relative to the plane of the ecliptic. It was a conjunction of events separated by unimaginable distances, yet connected by a single, terrifying timestamp. Part 3. The geometric veil of Saturn. The third, and perhaps most beautiful piece of the puzzle, appeared orbiting the ringed jewel of the solar system, Saturn. Saturn's rings are a masterpiece of chaos and gravity, billions of particles of ice and dust, constantly colliding, shaped by the push and pull of its many moons. The ring system is dynamic, complex, and utterly predictable under the laws of physics. However, a global amateur astronomy collective, monitoring Saturn's rings for the annual Mimas resonance shift, captured something unprecedented. A new, perfectly defined, faint K-ring had formed in the outer F-ring zone, This ring was not a cloud of particles, it was a structure. It possessed a lattice-like geometry that was visible only under specific infrared spectrums, forming a series of non-Keplerian shapes, squares, tetrahedrons, and perfect hexagons that rotated not by gravitational rules, but by an internal, synchronous frequency. The material forming the K-ring was not typical water ice. Spectroscopic analysis suggested charged silicates infused with rare earth plasma, and its formation was instantaneous, not gradual. It appeared overnight, on the very day the Voyager signal went silent. This geometric construction, defying the mathematics of orbit mechanics, suggested an active manipulation of the magnetic field lines. Saturn is a giant magnetic dynamo. Its rings are essentially vast plasma screens. The K-ring was acting like a colossal circuit board, holding impossible shapes in place through an unseen electromagnetic framework. Thorne theorized it was a triangulation point. The rogue planet Xylos, the charged particle field of the Oort cloud, and the magnetic field of Saturn were not three separate entities. They were nodes in an ancient, forgotten network. Part 4. The inevitable alignment. The ultimate realization lay in the calendar. The solstice of Eridanus. This wasn't a modern alignment. It was an ancient, calculated celestial moment when the center of the Milky Way galaxy, the plane of the solar system, and the most distant star in the Eridanus constellation that the ancients could track, all fell into a near-perfect 33.3-degree angle. This particular angle, according to obscure astronomical texts recovered from a forgotten observatory in the Himalayas, was called the angle of zero entropy, the point where the flow of cosmic energy achieves maximum coherence. Every event that had transpired, the calming field around Xylos, the perfect harmonic spike from Voyager, and the geometric formation of Saturn's K-ring, had been timed not to the modern Julian date, but to this ancient, almost mythic solstice. The hypothesis: what if the solar system, with its planets, its magnetic fields, and its plasma sheaths, was not merely a mechanical clockwork, but a vast, organic, resonating instrument? And what if Xylos wasn't a rogue planet, but a key, a massive, natural tuning fork, designed to enter a specific region of the Oort cloud at a specific time, to induce a coherent magnetic field resonance that would travel through the interstellar medium, strike the Voyager probe at the perfect instant, and finally, activate the solar system's primary magnetic node Saturn to display a geometric signal. The signal wasn't a radio transmission. It wasn't a light pulse. It was a structure. A temporary, perfect architectural arrangement in the plasma of the rings. A message written in the language of pure physics and geometry, lasting only a few weeks until the solstice alignment broke. The whispers carried by the solar wind were not random. They were the gentle hum of this cosmic mechanism coming to life after eons of silence. Epilogue. The deep hum of connection. As we watch the solstice pass and the K-ring slowly dissolves back into the random chaos of Saturn's dust, we are left not with answers, but with a profound sense of awe. The events suggest a vast, interconnected ecology of energy, where the movements of a single rogue body can ripple across light years and awaken ancient, dormant physics. It forces us to reconsider what coincidence truly means in a universe defined by laws we have barely begun to scratch the surface of. Perhaps the greatest lesson from Xylos, Voyager, and Saturn's geometric veil is this: we are not observers in a cold, silent universe. We are living within a massive, intricately wired machine that occasionally, gently, and with infinite patience, sends us a message written in the language of stars and magnetic fields. Rest now. Let your mind drift with the slow, resonant currents of the cosmos. The universe is awake, and its humming is the softest lullaby. Good night. This next story unfolds like a slow river of light, flowing through the galaxy and straight into your imagination. It is not rushed. It does not demand, only offers its calm, like the night sky itself. Begin by picturing yourself under a truly dark sky, no city glow, no neon signs, just you, the quiet earth beneath your back, and above you a pale river of light. That soft ribbon is the plane of our Milky Way, the view from inside our own spiral home. We are looking edge-on through a grand disk of stars, hundreds of billions of them, each one burning in perfect, silent persistence. If the night is clear, you'll notice mottled patches and dim lanes where dust clouds drift, sculpting the light into curtains and folds. That hazy beauty is not far away. It's our neighborhood, our address in the cosmos, and lying beneath it you can almost feel the galaxy breathe. Let your attention rest on a single star. It looks steady to your eye, a silver pin, yet that small light is a sun, with weight and heat and years enough to send you its glow across gulfs so wide they blur into time. The light you see left that sun long ago. It traveled quietly, never hurried, slipping through space until, tonight, it touches you. In this moment, you are reading an ancient postcard. Whatever your day held, messages, tasks, worries, none of them can chase light across years. You are safe here, held inside an old, patient story. Now, soften your gaze. The familiar patterns return: Orion rising in the cool months, Cassiopeia poised like a simple crown, the Big Dipper pouring toward the horizon. We call them constellations, but they're more like gentle chapters in a sky-wide book. Their shapes are not fixed. Over immense spans of time, stars drift with unhurried grace, rewriting the outlines of hunters and queens. The sky, you know, is a snapshot in a long, serene dance. Even change, on these scales, is tranquil. Let's wander inward, between the stars, into the interstellar medium space that is not empty but filled with thin veils of gas and dust. Imagine clouds so vast that a beam of light crosses them for years, and yet so delicate that a teaspoon of air on Earth holds more particles than a kilometer of that cloud. In these gauzy nurseries, gravity does its quiet work, tugging gently, gathering specks into clumps, clumps into knots, knots into hot, shining beads. A star is born not with a shout, but with patient accumulation, one grain, then another, until fire begins and a new light joins the river. Out at the edge of your vision, a blur blooms. The Andromeda Galaxy, our great neighbor. Its glow set out toward us when early humans were first finding their stride. Andromeda is huge, 1 trillion stars washing together into that single soft smudge. You can stretch out a hand and, with a fingertip, cover an entire island of suns. And in that gesture, you learn something gentle and important. The universe is vast, yes, but it is also reachable to the heart. Even a faint smear of light can carry the weight of millions of worlds and arrive as a whisper that says, "You belong here." Every so often the night sprinkles a brief spark, one thin line, then gone. A meteor is often a grain of dust surrendering to our sky, brushing the air so quickly that it burns, writing a single glowing sentence and fading with perfect timing. We pass through these dusty trails each year, and the heavens answer with showers that arrive like annual lullabies. Perseids, Geminids, Leonids, each with its own subtle rhythm. If you've ever made a wish on a shooting star, you've practiced the oldest astronomy, paying attention and letting wonder open a door inside you. Turn to the moon now, a familiar companion, gentle and constant. Watch its phases flow, a fine silver thread, a letter D, a chalky coin, a lantern strong enough to throw shadows across fields. Its light is sunlight, softened sunlight that has touched dust and old lava plains, bounced back and draped the world with milk. The moon's pull cradles the oceans into tides and, in a way, cradles us too. When its bright face climbs your window, you can almost hear a rhythm, slow as breath, reliable as sleep. And the wanderers' planets write their own calm notes across the sky. Venus glows like a candle held close. Jupiter steadies itself with a kingly brightness. And if you peer through a small telescope, you may see its 4 major moons, little pearls in a line, changing positions night to night in a miniature ballet. Saturn appears with a restrained majesty, its rings a thin hymn around a world of pale gold. No rush, no clamor, just orbits drawn with patient ink. Near the tops of the world, and near the bottoms too, the sky sometimes sings in color. Curtains ripple green and pink, as if the night has grown translucent wings, the aurora. Charged particles stream in from the sun and meet our air. Atoms glow, and the darkness becomes a living thing. You stand under it in winter, boots crunching, breath clouding, and you feel the quiet of cold. And above that quiet, a moving light that seems to breathe with you. There are places in the cosmos where matter thins, where entire superclusters give way to great, gentle voids. Imagine drifting through one of those vast clearings, where galaxies are rare and the dark is almost perfectly deep. Solitude there is not loneliness, it is spaciousness, the universe giving itself a wide, calm room. In such places you learn that emptiness too can be generous. Beneath everything hums a background, an ancient glow stretched into microwaves, the after warmth of a young cosmos cooling enough to let light slip free. It is everywhere at once, a faint blanket cast over all of space. Knowing it's there is like discovering that the house you're resting in has a heartbeat in the walls. A soft, steady reminder that everything began warm and bright, and has been unfolding, unhurried, ever since. Planets form the way rest arrives, bit by bit. Dust collects into pebbles, pebbles into rocks, rocks into bodies that sweep the path clean as they grow. Heat sparking, surfaces softening, atmospheres gathering like sighs. Millions of years pass without any need for hurry. And out of that patience come worlds some icy and blue, some stormy and striped, some silent, stony, and ready to cradle a tiny lake or a future footstep. Gravity is the quiet law that keeps every promise. It tucks you into your mattress while it conducts galaxies in sweeping arcs. The same pull that sets tides and bends starlight is the soft insistence you feel when you choose to stay, to rest, to let thoughts settle like snow in a still globe. When you exhale, you can almost feel gravity smooth the air over you like a blanket. Remember too, the silence. Space carries no sound, no echo of flame, no rattle of stones, only the choreography of light and gravity and time. If you've ever stepped into a forest after snowfall and felt the whole world hush, the sky's silence is that, multiplied until even your worries feel embarrassed to speak. In that quiet, the mind does not need to be loud. It can simply note, I am here, I am safe, I am small, and that is peaceful. Out beyond, quasars blaze distant, powerful, and by the time their signals reach us, very gentle. Their energy has been spread thin across unthinkable distances, arriving as a faint, ancient murmur. Even the universe's most dramatic events soften with time and space, teaching us that intensity can fade into harmony. During the day, the stars are still above you, wrapped in blue. They do not leave. They wait. That constancy is a kindness. The sky is never truly empty, merely veiled. If you were to rise above the air itself, you'd see them again, steady and honest, even while the sun stands bright. What is hidden is not gone. What is quiet is not absent. The Milky Way and Andromeda drift toward each other, and in a few billion years they will overlap, swirl, and settle into a new shape. It will look dramatic if you could watch it sped up, but in real time, it is a slow waltz stars, mostly slipping past stars. Night after night, century after century, until a new, larger calm emerges. The universe is an artist who never hurries. Every stroke is patient. Between clusters, the dark grows cool close to the coldest temperature nature allows. Think of that not as harshness, but as a perfect stillness, a room kept for deep rest. In such quiet cold, heat is precious, and every small glow, every candle star, feels like a friend. Stars live and stars rest. Small red ones sip their fuel for ages. Big blue ones burn with brief, brilliant vigor. Sun-like stars one day puff gently, shedding their outer layers into glowing shells that hang like lanterns in the dark planetary nebulae, delicate and short-lived on cosmic scales, brief artworks exhaled by a life well spent. The cores cool to white dwarfs, embers that shine on in peace. From the ashes of heavier stars, new elements scatter iron for blood, oxygen for breath, carbon for softness and sweetness. We carry star stories in our cells. There is a mystery woven into the fabric of space, a pressure that urges everything to drift apart a little faster than gravity would prefer. Dark energy, we call it, a name that is really an open door. You don't need to solve it to be soothed by it. It is the universe's long, slow tide, out, out, out. A promise that there is room to grow. For all of human history, we have looked up for direction. The North Star steadies our maps. Bright seasonal stars frame our harvests and our voyages. Even now, when satellites whisper us our coordinates, the sky remains a strong, simple compass. Look north, there is Polaris. Look east before dawn. The zodiac lifts another bright traveler. Guidance doesn't have to be loud to be true. Each observation we make, each sketch of a moon, each exposure of a distant cluster, each faint line in a spectrum is a page gently turned. The universe is a book with no last chapter, and somehow that is the most restful thought. You are not late to understanding. You are simply here for your part of the reading, and that is enough. Cosmic rays drift through all this, a fine, almost transparent rain of particles from faraway fireworks. They pass largely unnoticed, reminders that even in stillness there is a subtle exchange with the wider world. Quiet does not mean nothing is happening. Quiet can mean everything is happening without asking anything from you. Time, on these scales, is soft. It stretches, it flows, it forgives. Stars measure it in millions of years, galaxies in billions. When you hold your life against that canvas, worries shrink to manageable size. There is space to breathe. There is permission to rest. Lift your eyes once more and let them fill with starlight. See how the sky does not demand, it only offers. The longer you look, the more it gives faint clusters at the edge of vision, a dark lane you hadn't noticed, a slow satellite crossing like a moving punctuation mark. If your thoughts begin to wander, let them. If your breath slows, let it. If sleep approaches like a tide, welcome it. As you lie back under this wide, serene ceiling, remember, you are built from ancient light and cooled fire, from the dust of old suns and the water of wandering comets. The laws that hold galaxies together hold you together, gently and without fail. You are not separate from the night. You are a chapter of it. Let the darkness now be a cradle. Let gravity tuck the blankets. Let the moon stand guard at your window, and let the stars hum their silent melody, each one a distant lamp kept lit for you. There is nothing you must solve, nothing you must fix, nowhere else you need to be. The universe has been unfolding for eons without hurry, and tonight it invites you to practice the same grace. Breathe in and out. Feel the floor steady beneath you, the air cool on your skin, the quiet curve of your own pulse. With every gentle breath, the sky seems closer, as if leaning down to listen. Allow yourself to drift. The constellations will keep watch, the planets will move on their patient paths, and the river of the Milky Way will flow on, low and silver, until morning. Thank you for wandering with me across this calm, lantern-lit ocean. May your sleep be deep and unbroken, your dreams spacious and bright. Until we meet again beneath the quiet stars, keep looking up. Keep your heart open to wonder. And rest, knowing the universe holds you softly in its endless night.